What's going on, chat? How's it hanging? What is up? Hello, hello. Zig 0.12 release day. Very exciting stuff. I'm just going to pull it up and we could go through the release notes. Let's see. All right. New updates. In the past, these release notes have been extremely long, attempting to take note of all enhancements that occurred during the release cycle. In the interest of not overwhelming the reader, as well as the maintainers creating these notes, this document is abridged. Many changes, including API breaking changes, are not mentioned here. Correct. There are a couple ones. There's also some cool new reader support, which we'll see. Okay. Support table. The green check mark indicates that the target meets all requirements for the support tier. The other icons indicate what is preventing a target from reaching the support tier. In other words, the icons are to-do items. Find a reminder in here, please submit a PR. Tier 1 support means you can generate machine code, but the cross-platform, the standard library have implementations. libc is available when cross-compiling. Zig CC and Zig C++ tool chains are available. Okay, so yeah, these check out. Linux x86 64, working on it for x86. macOS ARM, good. Oof, dead on ARM. MIPS. Who's using Zig on MIPS? What router developer is using Zig on MIPS? RISC-V. Very cool. And our favorite, WASM. Freestanding and WASI, both supported. But it's possible that some APIs will give an unsupported OS compiler. They can link with libc. These targets are known to work but may not automatically be tested, so there are occasional regressions. Okay. Yeah. Looks good. Standard library has little known knowledge of the existence of this target. Yeah, that makes sense. We expect this. Tier 4, largely experimental. Can only support this target may only support emitting assembly and cannot emit object files. Okay. AVR, RISC-V, 32-bit. 32-bit macOS, 32-bit ARM macOS. Wait, there's a 32-bit ARM macOS? I mean, I guess that makes sense, but who is using that? Now deletes the previous experimental auto document from places with a new non-experimental one. The old implementation looked like this. $47 megabyte gzipped. Source autodoc.zig processed ZIR code, which is the intermediate representation of Zig code, outputting JSON data for web applications to consume. This results in a lot of code ineffectively trying to reconstruct the AST from no longer available data. Yes, that's very hard to do. libdocs common.js is a third-party markdown implementation that supported too many features. For example, I do not want it to be possible to have HTML tags and doc comments, because that would make source code uglier. Only markdown that looks good, both as source and rendered, should be allowed. libdocs Zig Lexer was an implementation of the Zig language tokenization in JavaScript, despite Zig already exposing its own tokenizer in the standard library. Bumping up the minimum requirements with using Autodoc. Yeah. So basically, the argument is like using a WASM tokenizer brings in string related issues that bytes have to exist in WASM shared memory. I don't know about this. I think that that's kind of like not a great reason not to use this. That's kind of a not great reason to do that. A little part of me died inside. Let's see. What's this issue? From the compiler into the browser and avoid unnecessary JavaScript files. 13 MB over the network for standard libdocs. Meanwhile, a tarball of standard library source files is only 2.1 megabytes. Oof. That is rough. I love this comment. I don't want to hear an excuse about passing strings over the WASM JavaScript boundary. There are various strategies to do it cleanly. You just need to use your imagination. That's very fair. So, like when we talk about using Zig over the WASM boundary, you just have to be a little bit more intentional about it. In rather than doing it back and forth of like incrementally doing it, it's just more effective to generate it all at once and then pass the whole thing and then reserialize it that way, rather than kind of constantly going back and forth between the boundary, which is like what is really common to do. In this particular repository, however, we need to demonstrate that Zig is a truly general purpose programming language. Please don't invest more in JavaScript logic. This should be Zig logic instead. Someone suggests adding Apache JSON to the docs folder. Yes, I like this a lot. This is really great. I like that this has been added. This is really nice. I'm curious on like what they actually did. We'll have to do a deep dive into that code one of these days. Source Autodoc renderer was a tool that converted Zig files into syntax highlighted but non-interactive Zig.html files. Okay, the new implementation looks like this. One Zig file, or two Zig files, and a bunch of JavaScript. Main.js, index.html, markdown, parser, render, document, main, walk. Okay. Total. After compilation, 12 megabytes, 2.3 megabytes gzipped. There we go. That's nice. As you can see, it is both dramatically simpler in terms of implementation as well as build artifacts. Now there are exactly 4 files instead of many, with a 4x reduction in total size of the generated web app. And or just one main.js. Let's see if we can pull that up. Lib. Docs. What is this? Oh, I know what this is. Okay, never mind. That's fine. So fetches the WASM. We can instantiate streaming. We give it a log and panic function. Cool. Very nice. We get the WASM exports. I don't know what this is. Window.wasm. I'll have to look into that. All right, let's see. Sources promise. Yep. Add event listeners. We render the title. I really like this. I think this looks really good. That's very smart. So realistically, what they did is they rebuilt it from the ground up and then actually handled the across the WASM boundary gracefully. Let's see, WASM. I'm curious what this extra in JS part is. I wonder if that's just like a calling convention, but we'll see. Yeah, this is great. This is awesome. I'm definitely excited to dig into this and see how we can use it for the Zig WASM code I've been building out as well. Cool. All right, continuing on. However, not only is it simpler, it's actually more powerful than the old system because instead of trying to process the Zig intermediate representation, the system processes the source files directly, meaning it has 100% of the information and never needs to piece anything together backwards. This strategy uses a WebAssembly module written in Zig. This allows it to reuse components from the compiler, such as the tokenizer, parser, and other utilities on Zig code. The source's tar file being compressed by the HTTP layer is fed directly into the WASM module's memory. The tar file is parsed using standard tar, and source files are placed in place with some additional computations added to hash tables on the side. There is room for introducing worker threads to speed up the parsing, although single-threaded, it is also already so fast that it does not seem necessary. This is great. This is really great for Zig and WASM. Honestly, to have their whole autodoc representation using WASM under the hood to parse the whole thing is awesome. In Zig 0.11, a Zig installation called the doc standard directory that contains those 47 megabytes of output artifacts. This rewrite moved those artifacts, offering the Zig standard command, which hosts standard lib autodoc spawns browser and diffuse. That is really nice. So now you get a Zig standard, so you can actually just look at the standard library doc directly on your machine. The HTTP server creates the request. Requested server creates the requested files on the fly, including rebuilding main WASM if any of its source files change, and constructing sources.tar, meaning that sources change to the documented files or the autodoc system itself are immediately reflected when reviewing docs. That's nice. Prefixing the URL with debug results in debug build of the WebAssembly module. This means contributions can test changes to Zig standard library documentation as well as autodoc's functionality by pressing refresh in their browser using only a binary distribution of Zig. Wow. That's really cool. That's so nice. In total, this reduced the Zig installation side from 317 megabytes to 268 megabytes. They're a 15% reduction. A release small build of compiler shrinks from 10 megabytes to 9.8 megabytes. Okay. Not as impressive, but still nice. Still good improvement. Autodoc generation is now done properly as part of the pipeline of the compiler rather than the tacked on at the end. It also no longer has any dependencies on the parts of the pipeline. This is how long it takes to generate a standard library documentation. Wow. It used to take upwards of 13 seconds. Now it takes 25 milliseconds. That is so nice. Reliable linkification is added. Interactive source listings. Press U to go to the source code for any declaration. Nice. Embedded source listings. Search includes doc comments. Very nice. Error set view, merged error sets are detected. Interesting. I don't really use a whole ton of error sets, but it is nice. Errors that come from other declarations are linked. Errors are also are also shown on the function view. Oh, that's nice, actually. Because, I mean, so that's all going to get emitted by the compiler. So generally you might have like bang here, but technically it's a set of errors. So it should be able to actually capture that for you. Language changes. Unnecessary use of var. Yep, this one happened in Nightly a while ago, which introduced a new compiler, which is emitted when a local variable is declared as a variable, but the compiler that can infer that a const suffice. Yeah, good. Result location semantics. This release implements forward result types through the address of operator. This allows syntactic constructs which rely on result types, such as anonymous initializations, and casting built-ins like incast to function correctly in the presence of the address of operator. Cool. I think I've maybe run into that once or twice. It's basically all you have to do is you split it apart. So you like get this value and then do it. It's not great, but it works. In addition, Zig 0.12 removes the ability for results locations to propagate through as an explicitly typed aggregate. This restriction is in place to simplify the language design. Previous releases contain several incorrect casting of result pointers. I could see how that could happen. Aggregate destructuring. Zig 0.12 introduces a new syntax to allow destructuring indexable aggregates, that is, tuples, vectors, and arrays. Writing a sequence of L values or local variable directions declaration on the left side of the assignment will attempt to destructure the value specified on the right side. So, destructuring an array. U32 const var yx, y plus equals 10. So that's saying that x is constant, but y and z are not. I don't know if I like that. I don't know about that. First field is a comp time field, so x is comp time known, even though y is one time one. Yeah, I don't know if I like that. That seems kind of weird. Like this syntax just looks kind of strange to me. Like I can understand it like this, right, where you have like I want two values here. That looks fine. But mixing constant var seems strange to me, and it seems like a really easy foot gun. I'm interested, but I don't know if I'll use it really. Slices cannot be directly destructured. To destructure values from a slice, convert it into an array by slicing with the comp time known value, known bounds, such as slice 0 to 3. Yep. So it still only works at you can't do it on slices. You can only do it on like declared arrays, which is fine. Namespace type equivalents in Zig, struct, enum, union, and opaque types are special. They do not use structural equivalents like tuples and arrays do. They create distinctive types. They have namespaces and thus may contain declarations. They can be referred to as namespace types. In 0 to 11, every time a declaration of a type is semantically analyzed, a new type was created. Equivalence of generic types is handled via memoization of comp time functions. Standard array list U8 equals standard because the array list function was only called once. It's namespace memoization is something I'm not great with. The captures of a type refers to the set of comp time known values. Comp time known types and values, which it discloses over. In other words, it is a set of values referenced within the type, but declared outside. This is way over my head. Let's see. Okay. Yeah, I'm not super familiar with this because I don't use opaque types very often. If ever. I think I've maybe used it once or twice. Comp time memory changes. Zig 0.12 overhauls the compiler's internal representation of comp time memory. More specifically, comp time mutable memory. This overhaul comes with some user-facing changes in the form of new restrictions on what you can do with comp time var. The first and most significant new rule is that a pointer to a comp time var is never allowed to become runtime known. For instance, I didn't even know you could do comp time pointers. I mean, it makes sense, but that's wild. Var pointer. Var makes pointer runtime unknown. Runtime known. Yeah. So I guess you could do that before. Yeah, because this is basically known at comp time, and then this is known at runtime, and they shouldn't be like, those shouldn't work. Such pointers can also become runtime known by, for example, being passed to a function called a runtime. When a pointer to a comp time var becomes runtime known, mutations to it become invalid since the pointed to data becomes constant, but the type system fails to reflect this, leading to a potential for runtime segmentation faults in what appears to be valid code. In addition, the value you read from such pointer from such a pointer at runtime would be its final comp time value, which was unintuitive behavior. Thus, these pointers can no longer be known at runtime. I think that makes sense. Like when you describe comp time and then you make it so that you can take a comp time value and assign it at runtime, that seems a little weird. Like I kind of understand why they would do that from a soundness perspective. The second new restriction is that a pointer to a comp time var is never allowed to be contained within the resolved value of a global declaration. For its instance, consider the following snippet. Yeah. Global variable reference contains reference to comp time variable. Yeah, it's like referencing this comp time variable. Pointer is a global declaration whose value is a pointer to the comp time var. This declaration was permitted in Zig 0.11. Okay. Code raises the same compiler as the previous error. Okay. I think we can skip some of this. Some of the comp time stuff gets like really crazy really fast. Admittedly, like one of the reasons I don't like to use it, I want it to be a little easier and a little more like sound, I guess, before I really dive into it. I've used it in a couple places, though. It's really useful when you're trying to print out like a struct or something. The first argument is removed in favor of using the result type. Field parent pointer. Yeah, that makes sense. Yeah, I like this. I like this syntax better. I like that you have to explicitly cast it rather than putting it as a param. I think that makes a ton of sense. Because then also it makes it really easy because you can put it inside of a function declaration and it'll convert it for you. Depending on what parent pointer alignment. Yep. Yep. Disallow alignment on function type. On function types to specify an alignment. Why? That's a little weird. Error cast. For a safety check cast from one error set to another. So you take an error and you cast it as a different error. Okay, cool. On absolute value function, on instance strings, standard library, Windows command line argument parsing. That's good to know that you couldn't do that before. Bring your own OS API layer regress. Previous version of Zig allowed applications to override the POSIX API layer of the standard library. Yeah, that makes sense. Ability to format F80 and F128 types, more accurate F16 and F32 formatting. Ryu floating point format. Let's look on this. Converts floating point numbers to decimal strings. Interesting. Now this is just built into the standard library, which is cool. Complete round trip support for every float type. Generic backend can be used to print any float of a general number of bits less than or equal to 128. So If you're not familiar in Zig, you can actually use non-normal bit length. So you could say like a float 34 or something like that, where you have a 34-bit float. This should be able to allow you to still print that. Exponents are no longer padded. Fractional values 0, omitted in full precision mode. Full precision output is more accurate in all cases other than float 64, since we do no longer do a cast internally to float 64s. Very nice. That's very nice. Additionally, rounding behavior in these cases can differ. In the fixed precision case is the simplest. So shortest representation will typically differ. Okay. Performance 2.3x performance per minute. Code size roughly 5 kilobytes. Okay, so it's larger in code, but it's more performance. Reworked HTTP. This is what I'm interested in. Some pretty straightforward changes. Don't emit server HTTP header. Let the user add it if they wish to. Let the user add it if they wish to. It's not strictly necessarily and arguably a harmful default. Correct the error set of finish to not have the not writable and message to log in it, protecting its zero length chunks and server. Add missing redirect behavior and fetch options. Make an EDM instead of 2 fields. New errors. Remove disabling. Remove documentation comments that were redundant with field types and names, with field and type names. Disabling Z standard compression in the server for now. Interesting. Do you have a link to that? This is a PR. I like that they're starting to remove the use of allocators from the standard library. I always thought that was a weird case because it makes it really hard to test, I think. So I think it's cool that they're starting to really pull out some of those pieces. That's cool. Okay. Automatically handle expect. Move the ability to heap allocate buffers for headers. The buffer for HTTP headers is now always provided via a static buffer. Interesting. That could be a big one because I don't do that. I'm pretty sure. I'm going to have to dig into that. Removal of standard at HTTP headers. I was familiar with this. We ran into this on our Zig Vermion router. Instead, some headers are provided via explicit field names populated while parsing the HTTP request response, and some are provided via new fields that support passing extra arbitrary headers. This resulted in simplification of logic in many places, as well as the elimination of possibility of failure in many places. Yep. Furthermore, it made it no longer necessary to clone the header's data structure in order to handle redirects. Yes. HTTP proxy and HTTP proxy fields are now pointers since it is common for them to be unpopulated. Yes. Load default proxies, change to init default proxies to communicate that it does not actually load anything from disk or from the network. The function is now leaky. The API user must pass an already instantiated arena allocator. Removes the need to deinitialize proxies. Before, proxies stored arbitrary sets of headers. Now they only store the authorization value. Cool. Remove the duplicated code between HTTPS proxy and HTTP proxy. Finally passing. Yeah. Great. Rework server entirely. Wait, send, finish function. Switch all operated on the same response object, which is actually being used as the request. Accept gives you a connection. Init, you init the server with the connection. You receive, gives you a request, gives you a body reader. You get a one shot. or response streaming, creates a response. You get a body writer and finishes the response. Okay, so we might have to read through this at some point. I want to keep Zig Fermion router as close to this as possible, so that we can swap it out. So that you can basically write your code and just swap the internal part a little bit. But also, I think we can start porting some of the things that we learned in Zig Fermion router to build on top of the HTTP server interface. So we can use some of the nice developer API pieces on top of the standard server. Streaming response bodies no longer wastefully wraps every call to write with the chunk header and trailer. Instead, it only sends the HTTP chunk wrapper when flushing. This means that the user can still control what happens when it does, but also does not add unnecessary chunks. Code is less noisy. It has a lot less error handling while handling errors more correctly. It's more obvious what's happening. Okay. Oh, I really like this, actually. We might have to implement that. That would be really nice. Because right now, like how we assign headers, I have an example of it somewhere. Static. Let's see. Like this. But under the new one, you could go like this. What is that, a header? Let's look. Yeah, it's like this. Oh, interesting. I'm curious. So what are we using here? Oh, we're using any type. Yeah, there was a reason why. Oh, so you don't have to specify the names. I think it might not be a bad idea. We'll consider it. That might be interesting. Because then we can convert this to yeah, because I'm just doing this. But like realistically, this could be like just to kind of highlight this. We could do and say we'll say yeah. Because right now I think internally it's just an array of headers. Yeah. So I don't know. Maybe if the Zig standard library is going to be verbose about it, then we probably will too. I don't want to stray away too far from that. I'd rather keep it close until there's some big change in it, unless there's some better framework that comes out with it. But I like the idea of like explicitly tagging it. That's a good idea. Uncouple the head parser. Delete standard connection. Use standard server connection instead. Okay. Deflate re-implemented from first principles. The deflate implementation was ported from the Go standard library, which had a bunch of undesirable properties, such as incorrect use of global variables, comments about Go's optimizer in Zig's codebase, and the requirement of dynamic memory allocation. Oof. The new Zig, the new implementation is roughly 1.2 to 1.4 times faster in decompression and 1.1 to 1.2 times faster in compression Compressed sizes are pretty much the same in both cases. The new code uses static allocations for all structures, doesn't require an allocator. That makes sense, especially for deflate, where all structures' internal buffers are allocated to the full size. Little less for inflate, where the previous version used less memory by not pre-allocating to theoretical max array size, which was usually not fully used. That makes sense. To deflate, the new implementation allocates 395K, while the previous implementation used 779. For inflate, the new implementation allocates 74.5, where the old one around 36. Okay. So it uses more memory to inflate, but to deflate, it's a lot more memory efficient. Inflate distance here is going to use a 64K history instead of a 32K. Okay, yeah, so then that's comparable. I like it. I think it looks good. Yeah, I mean, it shouldn't change much for you. That's nice. Standard POSIX APIs gain type safety. For example, let's look at standard POSIX terminos, the bane of my existence. Add missing API bits to terminos, and there's a type of fields for all 12 operating systems. Correct APIs built on Linux. They were wrong for certain CPU architectures. Consolidate standard.c definitions. Add type safety to all integers. Type safety! There we go. Yeah. Copy original settings, restore them once done. Okay, cool. Yeah, it was really hard to work with some of the actual, like some of these parts, because it's just the API was not as clean as some of the other parts of the Zig standard library. This thanks to new definitions based on pack structs. I don't love pack structs, but I'll take it. That looks good though. I'm into it. Standard built-in enum fields lowercase. Takes the opportunity to adjust the field names of some enums standard not built-in to align with their current name conventions, which dictate that enum field should be snake case. Good to know. I think all my enum fields are snake case. Global configuration. When one wanted to override defaults, such as logging function by standard log, they would have to define standard options of the root file. Cool. Note how standard options above is a struct type definition. In this release, standard options is now an instance of standard options, making the process of defining overrides less error prone. Cool. Yeah, this is a big one. Oh. Oh, that's nice. So that means we can actually replace this. So right now, we do this. See? Or it used to look like this, and now this is equivalent, which is this one. Cool. Options. Pointer stability locks. So another hash maps by adding lock pointers and unlock pointers. Cool. System package mode makes the Zig build system significantly more friendly to system package maintainers by introducing system integration options. Yeah, I don't know how that would. I'm a little confused by that one. We'll have to come back to that. Avoid fetching in system mode. Prevents Zig from fetching packages. Instead, a directory package is provided and populated, presumably by the system package manager. Oh. That's actually really helpful. Like Nix has a problem with this because it can't fetch during build time. Lazy dependencies. This makes a dependency only get fetched if it's actually used. The build runner will be rebuilt if any missing lazy dependencies are encountered. It is probably best practice to always use lazy dependency in build.zig. Can I do like module dot lazy import? Interesting. Okay. Yeah, I guess that's fair. This makes it so that the dependency only gets fetched if it's actually used. The build runner will be rebuilt if any missing lazy. This makes the dependency only get fetched if it's actually used. Okay. That's interesting. I could see a use case for this, probably. I think I'm trying to think. So like one example is like would it only fetch the parts? B.path, deprecate lazy path.relative. Yes, I used this yesterday. Header installation, compile, install header. The intent for compile, install header, and friends has always been to bundle the headers alongside an artifact, have them be installed. Modify the install top level build. Zig 0.12 make changes so that the install headers are added to the compile step instead of modifying the top level install step to handle the construction. Instead of modifying the top level install step to handle the construction of the include search path for dependent linking modules, an intermediary write file step responsible for constructing the appropriate include tree is created and set up the first time a module links to an artifact. Yeah, that makes sense. Has the second warrant removed and now use the value of include path as a subpath. Okay. Given a struct that corresponds to the build.zig of a dependency, returns the same dependency. In other words, if you have a imported dependencies build.zig file, you can use the function to obtain the corresponding dependency. Yeah, so like I have this, and then in the consumer code, that need to use their corresponding dependency. For example, pack should, returning the output. This would be independency build, let's say. Get important file path. Yep. The x86 backend, which is the big one. So on x86 projects, you get a pretty decent sized speed up, which is nice. Set the use LVM and use LLD on this false. This backend is now compiled many projects. Remaining tasks still can be selected by default instead of using LVMs for debug builds. 100% behavior test passing, improved debug info. That Windows stuff, don't really care. Zig now supports ELF for linking for x86, Arch, and partial support for RISC-V. Okay, so some caching changes. Compline pointer access. New toolchain upgrades. Very cool. Still working on Zig async. I think that not putting resources into async is not a bad thing right now. That's not the end of the world. All right, so let's go to Zig overlay. Let's make sure we can get it here. Maybe not, because it was... Nope, doesn't have the 0.12 version yet. Womp womp. All right, well, that's fine. We can just get the latest commit and call it a day. How often does this job run? Okay, so it'll run soon. Like, it'll probably run today, and we'll get 0.12. Interesting. Okay, cool. So I guess we'll have to get a Zig 0.12 build up on Nix packages first, and then we can do that. I wonder if it's on Nix packages. Let's see. Nope. Still 0.11. That's fine. I think we should be pretty much good. I just want to... What I'll go ahead and do is I will update all of my Nix flakes to whatever the latest version of the dependencies are, and we'll just use that for now. And then the goal is we'll get this one at least working on 0.12 today. Yeah. Maybe we can install, like, we can just put it on the path and use that instead. Ideally, I'd like to have that installed today so that we can just use it. Can I install spin on Nix packages? Like, Fermion spin 2.1.0. Let's just look at their GitHub. What's the most up-to-date version of spin? 2.4.2? Let's install spin here. I think most of my projects are using nightly. I think I just need to double check. See if it works. Very cool. Let's see. Yep. So that's the most recent one. That's okay. So that's the closest we're gonna get, I think. So once we get a new release, we can actually do that. But I think this should be close enough of a nightly to get 0.12 updated. Let's do a Zig build. Why did they do so much WASM? Okay, cool. Oh, this bug, man. I tell you what. We'll just do a full update. We'll get ZLS up to date as well. Casually gonna download like 5 gigs. Or yeah, great. Awesome. One of these days I'll just use like standard Zig or like, like standard Nix. I just won't use like nightly anymore. I don't know. I think it's good enough for now. Yeah, and then we'll pin the Fermion stuff, or we'll pin Zig tomorrow once it's out, which it should release tomorrow. Zig.0.12.0. I kind of want to fork the Zig overlay to do Zig nominated versions. I think that would be really nice. Let's see. I think we'll try to do a cut of also the Zig release notes. We'll post that as a separate video on YouTube. 0.12. Let's support our projects. Yeah. ZLS, come on. Hold on, let me check something. All right, there we go. Done. Perfect. Okay, cool. So now we have. Cool. Um, why is this timing out? No config file. Weird. Okay. Okay, cool. So that looks good. This one's good. We're gonna do the big one. Yeah, this Nix version is like way out of date. So this is the one that's gonna break it. Hopefully not though. This one has like almost no dependencies, so it shouldn't break. Except it does. Okay. All right. Yeah. There we go. Cool. Oh. Okay, cool. So yeah, we can clean that up. It's going to import from Sonic Records. Yeah. All right, so we're going to have to. Wait, can I do like const records? Yeah, I think we can just do that now. Oh, I know why. Records. It's not actually that. It's a Sonic. It helps so I can spell. There we go. That looks good. Cool. Is this because I'm no longer using args here anymore? Yeah. Because I'm not parsing arguments anymore. I don't know why I'm doing that, but okay. I guess it was just a test, so yep. Okay, cool. So this is like the records rework, really. I guess we added I guess we could probably redo these here. Not main. We want to do Fasta. So I totally I want to do these ones, and I want to do. Oh, I guess that is fine. Yeah. Yeah, I'm just dense. Yeah, those are just the pause exchanges, which we will do in a second. That's fine. There we go. Looks good. Yeah. This is the one I need to really fix because there's currently a lot of stuff in here that probably shouldn't be. So we need to clean this up a little bit. Yeah, we're getting there. But we should probably. I wonder if we can still Nix build this. Probably not. Yeah. Yeah, this doesn't have a release yet, so I should be able to do like this. Yeah, I don't know. I'm working on it. I'm open to suggestions though. I've been thinking about it. That's weird. Oh, I know why this is happening. Because it's like expecting it to be there. Have you seen TJ's? Yes. Yes, I have. Can I just like b.install artifact? Thanks, Copilot. But this isn't like a compile step. Let's see how ZLS does it. I wonder if they do anymore. We'll go to that in a second. I don't know what this Langref would be useful for. I might know what's going on here, but we'll have to see. It's this one. I guess we don't need to do this anymore. We can change the build.zig. Yep, we need strings now. Do we even have tests for strings? I have one test. Okay. Can I add like oh I can. So this one is like Sonic Test dot add import. So can I just see like the root module dot root? Yep. So now this will work. Cool. So there you go. Now you can go to results and you get your builds. One thing I did want to try is using the x86 backend on our executables here. So Sonic PDB and I wonder if I can do that here. Can I go here and do is there anything I'm building in this project that Cool. Good stuff. All right, so here's the part. Get Zig fetch. Let's see if this works. I don't think this one has any tests, so this one should be fine actually to build with Nix. Oh yeah, that's not gonna work. So that's fine. We have to fix that first. Nix flake update. Nope. This one I don't think I'm gonna do yet because I have some stuff I got to clean up in here. But a little sneak peek here, chat. Let's take a look. I got some client WASM code working, so I don't know if you saw my tweet about this, but I wrote some functionality to basically allow us to build WASM, like capture the externs of a file and convert them into WASM functions or into WASM exports. Because it's a little different because when you do client-side WASM builds, they're technically executables, they're not libraries, so you need some externs. There we go. But yeah, so it does all of that for you. It allocates your version or it allocates all these parts here, and then it reads through the AST, parses the file out, and then you're done. All right, let's take a look at something here. Yeah, we'll update the minimum Zig versions as well. I think we'll be fine for now. Okay, so this one, I think we already updated. I'm going to double check. Yep, already good. So this one's good. The one I know I'm going to have problems with. Where is it? What's it called? I have one that I know. Get C. See if this one even builds. Probably not. I haven't worked on it in a while. Oh, does Live Access even work now? I remember I had an issue with it because it just didn't work with libc builds. Yikes. Okay, maybe we won't do that. I guess we have to update that too. Oh, that's upstream, isn't it? That's in Vaxis, so yeah, I can't even update that one yet. Well, I think that's good. I think that's mainly all of the projects that I have right now that are like actually need to work at any given time. Um, and they all build fine. So I think that's good. Um, yeah, that looks good. That's solid. Is there anything else that I wanted to do today? Oh yeah, I was gonna do this. I think the reason I didn't is like you can't do like yeah. I thought there was something that I couldn't do from it, but uh, it's fine. Well, that's nice. So I got that added. Let's see. I think this is ready for my talk. Honestly, I think this is going to be really nice. I do kind of want to like have an example, so I might work on that later today and do that. I just want to get a scaffold of it before I stream it. But yeah, it might be cool to have a little code walkthrough that we can talk about. Okay, cool. Yeah, I think that's good. All right, cool, chap. Um, I think I'm gonna get going. Thanks for stopping by. For everyone who did, I appreciate it. Like I said, we'll probably take some time next week and dig into some of the cooler features of Zig 0.12. Also, like I said, we'll get all these ported over completely. Um, and I plan on pinning all my projects to 0.12 for anyone who's interested. So we'll pin that for a while, and then that'll be the case. 0.11 just did not have enough in terms of the build system, but 0.12 does. So we can pin that and call it a day. So yeah, I'm gonna go raid Chris, Mr. CM Griffin himself. I'm supposed to help him with some Neovim stuff. He hit me up and was like, "Hey, this is not working." And I was like, "Okay, cool." So I might hop over there in a second. So we'll go raid him. We'll see what he has to say, and then we'll go from there. But yeah, give me 1 second on that. Let's do it. Where's his name? All right. Thanks everyone for stopping by. Have a great rest of your weekend. If I don't see you, I might be on tomorrow. But if not, I will catch you all later. Take it easy, y'all.